Hello everybody, this is the video for Chapter 10, Application Layer. The application layer, as we've seen, is the top layer of both the OC and the TCP/IP models. As such, it is the closest to the end user and serves as an interface between the applications and the network. Application layer protocols are used to exchange data between programs running on the source and destination hosts. Some of the most widely used protocols are HTTP, FTP, TFTP, IMAP, and DNS. Presentation and session layers. Mainly, the presentation layer has three primary functions. It formats or presents data from the source device into a compatible form for receipt by the destination device. It handles the compression of the data in a way that can be decompressed by the destination device, and it encrypts the data for transmission and decryption of data upon receipt by the destination. The presentation layer formats for the application layer, and it sets standards for the file formats. Some examples are MPEG and QuickTime for video, and GIF and JPEG for graphics. On the other hand, the session layer, as the name implies, functions as the session layer create and maintain dialogues between source and destination applications. The session layer handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time. Now let's see something about the protocols. Although our models separate the application, presentation, and session layers, most TCP/IP applications incorporate the functionality of all three. These protocols specify the format and control of the information. Application layer protocols are used by both the source and destination devices during a communication session. For the communications to be successful, the application layer protocols implemented on the source and destination hosts must be compatible. Here are shown some of the protocols. So here's the same list of the protocols. I'll just name a few. DNS is a naming system that resolves internet names to IP addresses. Telnet. Telnet is used to provide remote access to servers and networking devices. It's important to note that Telnet is text-oriented. HTTP. This is the standard protocol to transfer files and make up the web pages of the World Wide Web. FTP is just another protocol used for interactive file transfer between systems. POP. Post Office Protocol, a protocol used by email clients to retrieve email from a remote server. And finally, IMAP, which stands for Internet Message Access Protocol, which is just another protocol for email retrieval. Now let's talk something about peer-to-peer networks. Peer-to-peer networks are very important nowadays since there are a lot of applications that use them, for example, BitTorrent. In a peer-to-peer networking model, the data is accessed from a peer device without the use of a dedicated server. In a peer-to-peer network, two or more computers are connected via a network and can share resources, such as printers and files, without having a dedicated server connected. Every connected device in the network, known as a peer, can function as both a server and a client, even at the same time. One computer might assume the role of a server for one transaction, while simultaneously serving as a client for another. The roles of client and server are set on a per-request basis. Let's take, for example, the picture. Peer 2 is the print server, because it has the print connected to it, and Peer 1 wants to print, so it sends the request to Peer 2. On the other hand, Peer 1 is the file server. So Peer 2 wants a file that is stored in Peer 1, so it asks for it, and Peer 1 acts as the server and Peer 2 as a client. Here I provide a picture to illustrate the differences between a server-based network and a peer-to-peer network. In a server-based network, all computers are connected to a server. However, in a peer-to-peer network, all computers are interconnected. In its simplest form, a peer-to-peer network is created when two or more PCs are connected and share resources without going through a separate server computer. A peer-to-peer network can be an ATA connection, just a couple of computers connected via USB to transfer files. A P2P network can also be a permanent infrastructure that links a half-dozen computers in a small office over copper wires. Or even a peer-to-peer network can be a network on a much greater scale, in which special protocols and applications set up direct relationships among users over the internet. Some peer-to-peer applications are eDonkey, eMule, Shareza, BitTorrent, Bitcoin, or Lionshare. Some of these peer-to-peer applications are based on the Gnutella protocol. They enable people to share files on their hard disk with others, as shown in the picture. Gnutella-compatible client software allows users to connect to Gnutella services over the internet and to locate and access resources shared by other Gnutella peers. Now let's take a look at the client-server model. Contrary to what we just seen in the peer-to-peer model, in the client-server model, there's always a computer that acts as a client and another one that acts as a server. In the client-server model, the device requesting the information is called a client, and the device responding to the request is called a server. Let's take, for example, when we enter Google. When we enter Google's web page and type something in the search bar, we are the clients, and we're asking information from Google servers. Although data is typically described as flowing from the server to the client, some data always flows from the client to the server. Data flows may be equal in both directions, or may even be greater in the direction going from the client to the server. For example, a client may transfer a file to the server for storage purposes. Data transfer from a client to a server is referred to as an upload, and data from a server to a client is a download. We can see this, for example, in Dropbox. Sometimes we upload our information to Dropbox servers, and other times we just download our files to our computers. In order to illustrate this principle and the advantages some of these applications have, here's a video from Dropbox website.
You've been there. You're about to buy lunch and realize your wallet is in your other pants. Or maybe you left your keys at home. The problem is organization. You need one place for everything, like a magic pocket. Putting something in the magic pocket means it's always there, no matter what you wear or where you are. The same thing is true for computers. If you have more than one, keeping track of all of your files can be a pain. Solving this problem is one of the big ideas behind Dropbox. It's like a magic pocket, a single, secure place for all of your stuff. Let's meet Josh, who is preparing for a big trip to Africa. Right now, all of his trip info is spread across his laptop, desktop, and phone. He needs to consolidate it all and is tired of having to email files to himself or move them around with a USB drive. Then he found Dropbox, which creates a new kind of folder on his computers. These folders work hard to be exactly alike, even across Macs and PCs. By adding his itinerary to his laptop Dropbox, he can be sure the same file will show up in his desktop Dropbox and even on his phone. The same thing happens when he saves a document in a Dropbox folder. The document gets updated across all of his Dropboxes. But it's not just his computers. The Dropbox website also works to be exactly like his other Dropboxes. Anything he puts in Dropbox is available on the website automatically. This way, if his Jeep takes a dive and his computer is ruined, he can still get to his files on the Dropbox website, where they're always backed up. As it turns out, Josh's Safari was a success, and his laptop made it home with lots of videos and photos to share. Instead of emailing everything, he just shared a Dropbox folder with his mom, so she could get copies of photos she wants to frame. Because it worked so well for travel, Josh made Dropbox the home for all of his stuff, so it's accessible anytime, wherever he goes. Whether you're traveling the world, running a business, or simply organizing your life, Dropbox means you can stop worrying about managing files and backups.
We've already mentioned some of the application protocols, but here we'll discuss some of them. There are many application protocols, but not all of them are used every day all the time. Here, we'll talk about HTTP, SMTP, and POP. HTTP is used to browse the web every day. SMTP enables users to send email, and POP enables them to receive them. HTTP is a request-response protocol that was created to retrieve HTML pages, which is the language used to give format. When a client, typically a web browser, sends a request to a web server, HTTP specifies the messages types used for that communication. Three common message types are GET, POST, and PUT. GET is used by the client to request data, while POST and PUT are used to upload data to the server. Although HTTP is remarkably flexible, it's not a secure protocol. The request messages send information to the server in plain text that can be intercepted and read. For secure communication across the internet, we use HTTP Secure, which is HTTPS. It is used for accessing or posting web server information. HTTPS can use authentication and encryption to secure data as it travels between the client and the server. It uses SSL to do this process. When we open our web browser, we instantly type a URL into the search bar. But what is happening behind? The URL is composed by three parts: the protocol scheme, which is HTTP, the server, which in this case is www.cisco.com, and a file that's been requested. In this case, it's index.html. When we press enter, the browser checks with the name server to convert the address into a numeric address, which is used to connect with the server. This is the process. Using HTTP, the browser sends a GET request to the server and asks for index.html. Then, the server answers back with a file, and the browser interprets it and displays the format of the web page in the browser window. We've all used email. Actually, we use it almost all the time. Let's take a look at how it works. Email is a store and forward method for sending, storing, and retrieving electronic messages across a network. Email messages are stored in databases on mail servers. ISPs often maintain mail servers that support many different customer accounts. An email client does not communicate directly with another email client when sending email. Instead, both clients rely on the mail server that transports messages. This is true even when both users are in the same domain. Email clients send messages to the email server configured in the application settings. When the server receives the message, it checks to see if the recipient domain is located on its local database. If it's not, it sends a DNS request to determine the IP address of the mail server for the destination domain. The email is then forwarded to the appropriate server. SMTP, or Simple Mail Transfer Protocol, transfers mail reliably and efficiently. For SMTP applications to work properly, the email message must be formatted properly, and SMTP processes must be running on both the client and server. When an email message is sent, the SMTP process of the client connects with the server SMTP process through port 25. It establishes a connection and tries to send the email. When the email is received, it either keeps it or it sends it to another server using SMTP as well. Now let's talk a little bit about POP and IMAP. POP, or Post Office Protocol, enables a workstation to retrieve mail from a mail server. With POP, mail is downloaded from the server to the client and then deleted on the server. Because email messages are downloaded to the client and removed from the server, there is not a centralized location where the email messages are kept. On the other hand, IMAP, or Internet Message Access Protocol, is another protocol that describes the method to retrieve email messages. However, unlike POP, when the user connects to an IMAP-capable server, copies of the messages are downloaded to the client application. The original messages are kept on the server until manually deleted. We can see the differences between POP and IMAP. So we can say that IMAP is good for small businesses, but large ones cannot hold the capacity of all the emails. And POP is desirable for an ISP because it does not store the emails. Now that we've seen something about email and communication through the internet, we need to talk about DNS. DNS is a protocol that receives a domain name and processes it, resolving it to its numeric network device address. A DNS server provides the name resolution using the Berkeley Internet Name Domain. also called as bind. DNS servers store different types of resources, records used to resolve names. Here are listed some of the record types. When a client makes a query, the server's bind process first looks at its own record to resolve the name. If it is unable to resolve the name using the stored records, it contacts other servers to resolve the name. It's worth to note that operating systems provide a utility called NSLOOKUP to resolve name servers to addresses. DNS protocols uses a hierarchical system to create a database to provide name resolution. The naming structure is broken down into small, manageable zones. Each DNS server maintains a specific database file and is only responsible for managing name-to-IP mappings for that small portion of the entire DNS structure. Because of this, DNS is scalable because hostname resolution is spread across multiple servers. The Dynamic Host Configuration Protocol, or DHCP service, enables devices on a network to obtain IP addresses and other information from a DHCP server. This service automates the assignment of IP addresses, subnet mask, gateway, and other IP networking parameters. If DHCP is not used, these parameters need to be set manually. The DHCP server chooses an address from a configured range of addresses called a pool, and assigns it, or lists it, to the host for a set period. It is more efficient to have IP addresses assigned automatically. So why should we use DHCP? Well, DHCP distributed parameters are listed only for a period of time and then are reused. And DHCP makes it possible to access the internet using wireless hotspot at public places. Now let's look at file sharing. First, let's look at FTP. The File Transfer Protocol is another commonly used application layer protocol. FTP was developed to allow for data transfer between a client and a server. FTP requires two connections between the client and the server, one for commands and replies, and the other for the actual file transfer. The client establishes the first connection to the server for control traffic, consisting of client commands and server replies. The client establishes the second connection to the server for the actual data transfer. This connection is created every time there is data to be transferred. The data transfer can happen in either direction. The client can download, pull data from the server, or the client can upload data to the server. Another way to transfer data is the Server Message Block, or SMB. It is a client-server file-sharing protocol developed by IBM in the late 1980s to describe the structure of shared network resources, such as directories, files, printers, and serial port. It is a request-response protocol. The SMB protocol describes file system access and how clients can make requests for files. Clients establish a long-term connection to the servers, and after the connection, the user can access the resources in the server as if they were local. Unlike the file sharing supported by the File Transfer Protocol, clients establish a long-term connection to servers. After the connection is established, the user of the client can access the resources on the server as if the resource is local to the client host. Now that we've finished, let's take a global look of how messages travel through a network. First, the application layer sends the get data to the transport layer. Then, the transport layer divides the application stream into segments and adds the TCP header. After that, the transport layer passes the segment to the internet layer, and there, the internet layer creates an IP packet, which is then sent to the network access layer and converts it to electrical signals. Through this process, we can follow down the chain and understand how messages travel through a network. I hope that you enjoyed the video. Thanks. See you later.